So let's look at another arc length problem. So for example, let's say I want to find the arc length of the curve given by r of t is ti plus 4/3 t to the 3/2 j plus 1/2 t squared k from t equals 0 to t equals 2. So again, if I'm going to find arc length, I need the derivative r prime of t. It's going to be I plus 2t to the 1/2 j plus tk. So now the arc length, if I plug into my formula, s will be the integral from 0 to 2 of the square of the magnitude of this vector right here. So it'll be 1 plus 4t plus t squared So then I'm going to rewrite it so my terms are in descending order here. T squared plus 4t plus 1. And then I'm going to complete the square inside of the square root. So I take half of 4, that's 2. And there I square it, so that would be 4. So I need a plus 4 here, but to balance that out, I'm going to put a minus 4 there so that it stays the same. And now if I factor this first part here, it'll factor into t plus 2 squared minus 3. And then I'm going to do a u substitution here. I'm going to let u be t plus 2. Well, du is dt. So now I'm going to have the integral from the square root of u squared minus 3 du. And then my new bounds on my integral, t was from 0 to 2. So if I plug that in here, I'll see that u goes from 2 to 4. And now I'm left with this integral. And in order to compute this integral, you're going to have to use trig substitution. So this might be a good place to stop and refresh yourself on integration, in particular trig substitution. The substitution you should make here will be u is equal to the square root of 3 secant theta. Well, then du will be square root of 3 secant theta tangent theta. And for now, I'm going to just look at this as a indefinite integral. So I'm taking off the bounds here. I'm going to plug in my trig substitution. So when I square u, I'll get 3 secant squared theta minus 3. And then du gets replaced by square root of 3 secant theta tangent theta. And then we simplify this right here to square root of 3. That simplifies to square root of 3. The square root of secant squared minus 1. But that's really just the same thing as tangent squared so now I'm getting, well, I'm going to combine this square root of 3 and this square root of 3 to be a 3 secant theta, and then we have 2 tangents, so it's tangent squared theta d theta. And then you've got to remember how to integrate trig integrals. So here we're going to have to use an identity. So this will be tangent squared is secant squared minus 1. And then this is 3 times the integral of secant cubed minus the integral of secant. And then these you learned back in Cal 2, so I'm just going to tell you what they are. So we're getting 3 times, so for secant cubed, you get 1/2 secant theta tangent theta plus 1/2 ln secant theta plus tangent theta. And then for secant theta, we have a minus here, so it'll be a minus ln secant theta plus tangent theta plus c. And so here's where we have to go back to our substitution. Our substitution was u equals the square root of 3 secant theta. So if I solve for secant theta, it's u over the square root of 3, which I can use to plug into my secants in my formula. But I also need tangent. So you're going to have to draw a triangle here. And let's see. So if secant is u over the square root of 3, you would get hypotenuse over adjacent. This missing side will be u squared minus 3 square root. And so from here you can read off what is tangent of theta. Tangent is opposite over adjacent. It's the square root of u squared minus 3 over the square root of 3. So we can plug that now in place of tangent in our formula here. So let's go ahead and do that. So what are we getting? We're getting 3/2. I'm going to go ahead and distribute that 3. Secant is u over the square root of 3. Tangent, square root of u squared minus 3 over square root of 3. Plus, well, if I can combine these into a minus 1/2, I can combine this one and this one into a minus 1/2. So it'll become a minus 3/2 because I distribute my 3 ln of u over the square root of 3 plus the square root of u squared minus 3 over the square root of 3 plus c. So here in the first term, these two square roots of 3 cancel with that 3 there. And I can switch back now to my definite integral. So remember, I was looking for the integral from 2 to 4 of u squared minus 3 du. So if we plug in 4 for u, you're going to get 4 over 2 square root of 16 minus 3 minus 3/2 ln of 4 over the square root of 3 plus the square root of 16 minus 3 over the square root of 3, and then minus, and now you're going to plug in 2 for u, so you'll get 2 over 2, the square root. If I plug in 2, I'll get 4 minus 3 minus 3/2 ln 2 over the square root of 3 plus the square root of 4 minus 3 over the square root of 3. And there's my answer. You can simplify this if you want down. This becomes a 2. This whole thing is just 1. And that's just a 1 as well. But this would be my answer right here for the arc length of that curve. It's not pretty, but we want to make sure and remind ourselves that we need to remember our integration techniques. So now might be a good time to refresh yourself on those.